Right, so we'll draw it. You've got 12.4 volts you've got a 4 ohm, a 5 ohm and 6 ohm. And what did they want at the start? The 6 ohm, is it? Current in the 6 ohm. So I think it would be helpful to work out, oh no, they want the potential difference. Although I think it would be helpful to work out the total resistance. So the total resistance, hang on, it's 1 over 4 plus 1 over 5. Let's see, that's over 20, isn't it? 9. So the resistance in these two is 20 over 9. Yeah, but I have to add on the 6. Are you giving me the total there?
Oh, so it's 8.2.
Is that the total? 8.2 ohms. So we can use Ohm's law, V equals I or. So 12.4 equals I times 8.2. So I have my answer for the first part. It is, oh no I don't. Well I have the I, which I need. The I is 12.4 over 8.2. What's that please?
1.51.
What does it do, go?
1.51.
Okay, amps. Now I can use Ohm's law. V equals I or. What's the I? 1.51. And what's the or here? 6. So the answer is? Very good. Whatever. Oh look! I accidentally did the second part. Did I? Oh no, I didn't. No. Almost. Yes. If the voltage here is 9.05, then the voltage here must add together to make 12.4. So yeah, so what's the voltage here? 3.35. Yeah. So you know the voltage here is 3.35. So we can just use the law again. V equals I or. I equals V over or equals 3.35 over 5, which is?
0.67.
And finally they want the power. So the power, what formula? You have IV, but V equals I or. So this is I squared or. Now you know what the I is, nearly. Because what's the total is 1.51. The total here is 1.51. And how much is in this piece? See, it splits into two. This one here, what was it? 0.67. So then how much current is in this piece? 1.51 minus 0.67. What's that? Come on, children, please. 1.51 minus 0.67. 1.24. Isn't it? No, that's wrong. That's totally wrong. No, I can do this. Hold on. That's a 4, that's a 1, that's a 4, that's a 0, that's a 1, that's an 8. 0.84. 0.84 amps. And what's the resistance? 4. So this here will be 0.84 squared times 4. What's that? What is it?
I don't think it's that.
Yeah, it could be. Now, I'm going to do this again, but this time I'm going to use what? What's the other way to do this? Bingo. So Kirchhoff this time. 6, 4, 5, and 12.4 power. Okay. So, you know how Kirchhoff works. Let's say it's going this way. I1, and then what happens here? I2 and I3, I2, I3, and then what's this one here? I1 and I1. Okay, let's use junction rule here. Yeah, I1, yeah, or minus I2 minus I3 equals 0.
You're always useless. And you back.
Yeah, no, I see that now. Okay, now let's use loop. How many loops will we need to make? We need to make 2 more loops, good. So let's start here. We have 12.4. What's next?
9.6, which is 9.05.
How do you know that?
Just
I know, we're pretending we're doing the questions in the start.
Oh, sorry.
Yeah. Next? Yeah.
Equals 0.
Okay, next one?
12.4.
12.4.
Minus 4 is 6 I1.
Yeah.
Minus 5 I3.
Yeah. Equals 0. So how many equations do you have here? 3. So could you solve for I1, I2, and I3? You could. And then, don't forget, in each of these i's, you have v equals I or. Now, do you know the i's? You do. And do you know the ors? You do. So you can very easily get v1, v2, v3. So we all are good math students. So we know how to find I1, I2, I3, don't we? So I'll just use the computer program to get the answers here. You're happy with me doing this? Yeah? So we should get the same answers. What? Oh dear. Okay. Let me just move this over to here now. V1, V2, V3. And by V1, V2, V3, V1 is the voltage in this one, V2 is the voltage in this one, and V3 is the voltage in this one. In fact, I know V2 and V3 are the same because they're in parallel. Did you write down those equations? Because I need you to read them back to me. Okay. So, Abraham, where's my program? Here. What's the first equation? So, x minus y minus z equals 0. Next one?
12.4 minus 6x minus 4y
Equal 0?
0.
Yeah.
12.4 minus 6x minus 5z.
Solve system, 3 of them. Number 1, number 2, number 3. Oh yeah. X is 1.5, y is 0.83, and z is 0.67. Which answer do we need? For part 2, what do they want? The x, y, or z? The current in the 5, which is z. That is 0.67. That's the answer I got the other time, isn't it? What do we need for part 1? The voltage in the 6, which will be V equals IR, so that is 1.5 multiplied 6. What's that? Is that what I got the other time? Good. And the last one is the power, which is I squared R, which will be the Y answer squared times 4. So 0.83 squared times 4. It's the same answer, isn't it? So which method do you prefer, Ohm's law or Kirchhoff? Oh, very fine.
I think it depends.
Nobody likes Kirchhoff, it makes me
I
sad.
think it depends on the situation.
Okay. Yes?
For the third part, can't use V.
Oh yeah, you can also use, because we have the I and the B, you're right, you can use ID, so it would be
The current.
0.83 times the V, which is IR, which is 0.83 times 4, which is, what is it, whatever. Yes, that's fine.
But the current in parallel, it's not shared equally, right?
The current in which one?
Parallel circuit.
Oh, it's not shared equally, no.
The resistance are shared equally.
Well, okay, if the resistance is the same, it's shared equally. Usually not. Yeah. Yeah. Okay, nobody likes Kirchhoff.